Hello everyone, I'm Ahmed Hassan, a PhD student in the Institute of Combustion Technology in RWTH Aachen University. I'm working on sub-project P8, which is part of OxyFlame grant, which is responsible to do sensitivity analysis and uncertainty quantification of solid fuel combustion. This work has been done under the supervision of Dr. Tani Zadeh. So, the combustion of solid fuel at different configuration, as the shown example of a jet of point particles, provides lots of information about different quantities of interest, as ignition time, heat release, and so on. If we zoom into the simulation, we find many models parameters that govern the system. For such large number of parameters, traditional methods of sensitivity analysis aren't feasible. So, we use adjoint method, which is an effective approach for large systems. Afterwards, the extracted gradients are used to do uncertainty quantification to different experiments and simulations data. We analyze the sensitivity of single particle with respect to different system parameters using different schemes. The first one is to identify the most sensitive parameters, as shown in this figure for particle temperature, for example. The second is to use this information to create sensitivity maps for the most dominant parameters in the system, which allows us to identify different regions with different characteristics. The sensitivity map of heat release gives a solid example on that. The third is to change the scope of the analysis from point to resolved particle to consider the hydrodynamics effects and the variation of sensitivities around the particle surface. The variation of drag sensitivity around cylinder surface is an example. Afterwards, we investigated the sensitivity of resolved particle with different shapes. As shown in this graph, the drag sensitivity distribution over an ellipse surface is much higher than a cylinder surface. So, changing shapes from bluff to streamline body affects the sensitivity largely. Moreover, analyzing particle cluster shows different drag sensitivity for each particle in the group, but with a similar behavior for high and low Reynolds number, as it's shown in this figure. Thank you.